Welcome to testing the lighting with Mark. No. Also, yes, because we are playing with the lighting. I don't like that shadow. We'll have to figure that one out. So much to figure. Lighting is very, very hard. Sound is impossible, but lighting is very, very hard. I think one of the things we're missing in software engineering, aside from testing anything ever, which is the only way you can improve or learn or know that you've done something wrong. It's a little weird that no one's testing anything anymore. You would say, Mark, of course they're testing. I'm like, all right, if I have a product and it's broken, you didn't test it. Period. End of statement. It's not that hard. It doesn't have to be hard. You don't release bugs if you do testing. Sorry, just the way the world is and always has. It's definitional, actually, right? You didn't do the action before that prevented the action I see now, then I see that action. Therefore, you didn't do the action before, which would be the testing. But that's not the big problem. The big problem is because we're not testing, there's a side effect. That side effect is that we don't notice architectural problems until they're too late. Updated cursor yesterday. An hour later, they sent another update, or maybe 2 hours later. I was like, what is going on? Oh, look, I'm having all these connection problems, at least according to the GUI. Like, oh, I can't connect back to the network. I'm like, well, everything else can connect to the network. How many man hours, we'll say millions of man hours, did you spend to break network connections? Network connections have been known and able to be done since the 1970s. It's now 2025. I don't understand. I actually don't understand. What on earth did you do well? Separation of concerns problem. Right. The network code should be separate from all the other code, right? Because all it does is, make network connections and pass messages across, right? And that's a encapsulatable function that can just be used in the call stack from outside modules, right? Depends on how you want to build your software, right? I would suggest it be a library, but whatever, doesn't matter. When you have a connection problem, since you never should change your network connection code ever, pretty much, like you should figure out what kind of protocol you're using within the TCP/IP protocol suite and just use that. There's no reason it should break ever. Now, it's possible that it wasn't broken, but something else was. But again, this is a problem of separation of concerns. That code shouldn't be broken, and therefore that error shouldn't come up. So if the error is coming up, you don't understand your own separation of concerns, even if it's correct. How do I know which it is? Well, there's no testing, so you can't really figure it out. And I bet the engineers couldn't figure it out either, actually, because without separation of concerns, especially if you're dragging in all your code from libraries, which again, I did an actual study on this. 90% of the code, all the clients I worked with, was not theirs. It came from other sources. It came from open source or from vendors or whatever. So the code they're compiling might be huge. Their binary might be enormous, but the amount of that binary, the amount of the code that was written, is less than 10%. I don't, what separation of concerns were the vendors using? What separation of concerns was done in the open source project? One of the last big projects I worked on, like they had 3 database layers. 3. Of course, this caused all kinds of problems because each database layer made its own object set copy of every object that you read from the database. Right. And then it turned out you know how many they needed? None. They could do all the calls in JavaScript. There was no need at all to have a layer in Java that was handling the database for them because they could just make the calls directly in SQL. What were they doing with that database layer? I don't know, but they had 3 of them and there was no separation of concerns because basically what happened is everything got called 3 times because aspect-oriented programming is stupid and you don't know with decorators what you're calling. You can't see the call stack. If you can't see the call stack, really, you need to do something else. Right? You're never going to debug software if you can't see the call stack. It's virtually impossible. And these things that obfuscate call stack, like decorators, need to be used sparingly, if at all. I've never seen the use for decorators ever. ever. I understand you can do cool things with test-driven development. Also, test-driven development is bad. So, okay, you can do the bad thing faster and better. Great, thanks. Test-driven development is a terrible idea. Terrible. The thing that should drive your development is your customer requirements. That's what should drive your development. You know what else should drive? Nothing. Nothing else should drive your development. And your customer requirements driving your development means you need to design something, architect, right? Software architecture, to meet those requirements. And then you have a decision to make. How much of the complexity goes in systems architecture and how much complexity goes in software architecture? Because again, maybe if there had been one database framework that they were using and they were just calling that from the web interface, the software would have worked because they would have proper separation of concerns. I'm not saying that would have fixed it. It probably wouldn't have. There were other problems, but proper separation of concerns might have been much faster because the server was doing server-to-server communication instead of client-server communication. Right? There's all kinds of reasons, right? Or do you put the complexity in the software on the client side, right? Because you also have to decide how much complexity goes in the server, how much complexity goes in the client, right? These are all decisions that you need to make based on the thing that's driving your development, which should always be your customer requirements. Oh, why would anybody have to tell anybody else that? I have no idea. No idea. It just gives me a headache. So when you understand these things, then you can start to encapsulate the functionality. So you don't have bugs up here affecting things down here, like your network stack. Or you have a bug that's so ambiguous that you just think it must be the network because I don't know what else it can be and we didn't log properly. When you have proper separation concerns, your log files go down to, megabytes, if not kilobytes. Right, it's a big deal. Now you can read the log files instead of having a 5 gig log file trying to trace a database problem on a 2-minute, I'm not joking, a 2-minute connection. You generated 5 gigabytes of log file data in 2 minutes? What on earth are you logging? Well, in Java, with aspect-oriented programming, probably every piece of code that's in the system, whether it's running or not. Or rather, whether it's needed or not, it's all running and logging for no reason because it's not being called. Right. No separation concerns. This is why decorators are dangerous. Oh, this software, this piece of code runs every time you run this other piece of code. That's great. Do you need it every time? No. Why are you doing this to yourself? Right. That's a problem. All in the name of testing. Right. Look, you should be able to debug your program with printfs. If you can't do that, I don't know what to tell you. You've made it way more complicated than it needs to be, for sure. And some things need to be complicated, but almost nothing needs to be complicated. And if it needs to be complicated, you're not the guy. You're not the guy. That's all. It's not that hard. And we have a lot of people doing things the most complicated way, dragging in libraries. They don't even know what the libraries are for, and therefore they're using them wrong. And then you get database connections that take 4 minutes. Right, to an Oracle database backend that runs, could do 4 minutes, could process 2 trillion rows in an Oracle database. Like, I don't even know what you're doing in 4 minutes. Right. That's not the database's fault. Database runs plenty fast. So you get these side effects all the time because it's not proper separation of concerns. And you can't have proper separation of concern in test-driven development because test-driven development doesn't have concerns. It's just basically code validation. The problem is you can lock down your code all day long, but that's not going to prevent any bugs at all. This is why the memory safety and Rust thing is such a red herring. It doesn't prevent any bugs. It doesn't prevent any bugs at all. It doesn't make your software more secure. I'm running software that I've been running. In fact, in the past, I ran software for like 15 years straight. It was always up. It was on the internet, directly connected. Had all kinds of memory leaks. Never got broken into. You know why? Because you couldn't break into it. Well, but it had memory leaks. Yeah, but it wasn't exposed to the network. The front end was, but the front end didn't have any memory leaks. Well, if the front end doesn't have any memory leaks and you sanitize all the data going to the back end can have memory leaks all day long. And the worst that can happen is you can crash the program. But since they were buffer overflows, and the buffers could never overflow because the front end prevented buffer overflows, the fact that there were buffer overflow C code in the back meant nothing because it was never a concern, because that bug never manifested. That's what separation of concerns buys you. Security, like actual cybersecurity. That's why we didn't have cybersecurity in the past. The whole idea of the cybersecurity industry is like 15 years old. It comes out of the military, but it also comes from the fact that when you don't do proper separation of concerns, you create a problem that didn't exist, which is cybersecurity. And people don't know any of this for whatever reason, but this is the history, man. This is how it all unfolded. Like, no one had security problems back in the day. Everybody knew. People used to make jokes out of writing C programs that would buffer overflow on purpose. And the early version of VMS had a buffer overflow in the login prompt. So I think even if you just type backspace, it had two different bugs, but if you just type backspace at the login prompt, it dumped you in as root at ring 0 in the VMS. That's David Cutler, by the way. So he then went on to Microsoft to put equally heinous bugs all over another operating system. I don't know why anybody likes that guy. He's terrible. Terrible architectures, terrible results, terrible. VMS didn't get stable till after he left the deck. I don't know. That might have been a hint, guys, but whatever. And these are the little things nobody knows. Right? Early architecture of Windows NT, the original version, right? 40,000 clock cycles per I/O operation. DOS, 4,000. Big difference. DOS was much quicker. Why? Because they were following a PhD-laden architecture of separate buffer and cache for everything, which just turns out to be a dumb idea in a kernel. I could have told you that back then, but whatever. No one asked me. They were busy paying David Cutler too much money to make a horrible operating system. The terrible design that took them like over a decade to make work properly and not crash all the time. So whatever. Separation of concerns. And that's actually the early NT kernel and like the early Mach microkernel. It's a good example of too much separation of concerns, right? They're going into the kernel level and separating the parts of the kernel out from one another. And it's like, what are you doing? Like, no, the kernel should be monolithic, period. You shouldn't use modules in your kernel ever. I mean, there's cases where you need to, but like you should just avoid that like the Black Death, man. There's no reason to do. Your kernel runs so much faster when it's not running modules. It's not even funny. It's a huge noticeable difference, or at least it used to be. I haven't done any benchmarking on Linux kernels in a while, but yeah, even the DKMS, the early DKMS stuff, no, sorry, not even close. The monolithic stuff was quicker because it could make certain optimizations in the compiler that you can't make when you don't have the code up front because it's a loadable module. It's just that simple. It's not that hard. There's optimizations that can't be done if the code isn't there at compile time. So it makes sense that would be the case, right? And those small optimizations in the kernel are large speed differences after when the kernel's running, like large. So that's really the difference. And people don't understand that. People don't understand separation of concerns. Super important. Design is super important. You have to architect your software. You can't just start writing it. That's nuts. But the start writing stuff is a RAD concept, right? Rapid application development. That's things like Python and Ruby were built for RAD. They weren't built for production. I'm not saying you can't use them in production, but they weren't built for that. They were built for rapid application development so that you could wireframe something that worked and hand it to your customer. And then you would go back, this is the RAD principle, you go back and code it in a real programming language like C, because C++ isn't a real programming language, it's a piece of garbage. So Java too. Java was originally designed for embedded systems. Like, if you're not writing an embedded system, don't use Java. Please don't use Java ever, unless you're doing an embedded system, in which case Java is completely unsuitable because it's too big for an embedded. Originally for embedded systems, it's too large for embedded systems. I don't know what was going on at Sun. I have no idea. Java's garbage. Always was. Always will be. Sorry. I don't know what else to say. Impossible to debug. 5 gigs of log files for 4 minutes of runtime. Only Java could achieve such a feat. You'd never get that way in C. It's impossible. The amount of code you'd have to write would exceed your ability to write it. So yeah, separation of concerns. Separation of concerns. In all things. It's not just a software concept, right? Right? You don't want to tether your car to your house, right? You want those concerns separate so your car can go off and come back. But it's so easy because we're not testing, because we're getting no feedback, because nothing's set up right anymore. We've lost all of these concepts. And they're the concepts that made all the software that is still running the internet and has changed very little. You'd be surprised how old some of the internet infrastructure is in terms of code. And I've talked about this before. If you haven't seen Buffer Bloat, that look up the history of Buffer Bloat. See if you can find the original blog entries which he was putting out at the time he found that problem. Right? All these new engineers couldn't fix it. You had to call Van Jacobson, one of the original engineers on the TCP/IP protocol. It took the guy 2 weeks or something to fix it. I was like, what the hell? These people are not human. No one else could fix it. They couldn't even find it. We've lost troubleshooting skills. We've lost coding skills. Coders today are terrible on average. They're awful. And that's because they don't have separation concerns, because we're not doing testing. It's all a mess. Make software great again.